Hi, welcome to Separation and Mixtures video. So in this video, we're going to talk about several different physical separations. So you're going to notice that column, the second column in your table there. And every single one of these is going to be physical. So the first technique we're going to talk about is filtration. None of these involve doing any chemical changes. These are all physical changes. So filtration is a technique that works when we actually things that are different sizes. So you take something called, or some sort of mixture, we pour it through a filter, and something moves through called filtrate, and larger particles, generally solid particles, stay on the filter. So what you can see in these three diagrams up here, this is showing pretty sophisticated filter. We have these large red particles that are not able to move through that. The smaller blue particles come through as filtrate. In a lot of labs, we don't do a ton of labs where this is applicable, but you can actually use something called filter paper. And if you have certain types of mixtures, you can pour them onto filter paper. So it's sort of like what coffee filters do, and those larger particles stay on the paper. So you can, a nice visual of this is orange juice with pulp in it. The pulp would get stuck here on this paper filter if you imagine doing this with a coffee filter, and what will come through is going to be that kind of liquid juice that does not have very much pulp in it. Downside of filtration is this will only work for heterogeneous mixtures because it is separating things based on particle size. So if you don't have differently sized particles, you cannot use filtration. Filtration cannot be used for salt water because the size of the salt particles is so similar to the size of the water molecules. So, if you could make a really sophisticated filter that would allow those to be separated, that'd be great. You'd be very rich. But because they're so similar in size and the way they're associated with each other, that's not really all that easy. So the weakness here is this is really when we have to have heterogeneous mixtures with very different particle sizes. Evaporation can be used a lot of times when filtration cannot. So again, this is a physical separation because we're physically changing water to separate it away from a solid dissolved in it. So the picture that's up there is kind of the lab application of this, but if you imagine, just putting some salt water into a container and boiling it, the salt gets left behind. You'll also see this on your pants in the wintertime. If your pants get a little wet with the, salt water that's on the streets, later you can kind of sometimes see like a little line there of salt. So you're evaporating away your liquid solvent. Frequently we're talking about water here, and it leaves behind that solid solute that was dissolved. So this is useful because it's going to separate homogeneous mixtures. So if your particle size is similar, but you do have different boiling points, which frequently you do, this physical separation will work perfectly. You just boil away that water or liquid and leave behind your solid solute. Distillation is a separation based on boiling point, where we actually could take different liquids if we wanted to and separate them this way, or solids dissolved in a liquid. So distillation separates various components of a mixture based on their different boiling points. One of the places that this is used in a huge industrial scale is the distillation of crude oil. So crude oil is dug up. It has a lot of stuff in it. It has kerosene, gasoline. It even has stuff like Vaseline and things like that, and wax we make candles out of. All those components have different boiling points. So they're heated and pumped into a column where they're able to be separated. And we'll talk more about that during organic chemistry. So when you're using distillation, we also will use distilled water a lot in lab. It's a way of purifying water where you take tap water, which has a lot of stuff dissolved in it. You boil the water. The other components, the scale, minerals, things like that, stay behind in the solid phase. What you can kind of see is happening in this picture. So your impure water right here gets boiled. The H2O leaves, impurities stay behind. You have kind of a cooling chamber that will then cool that water vapor back down, and it drips out as a liquid. I think sometimes you also hear a lot about this with like bootleggers and people distilling liquor and that kind of stuff. That is how those beverages are purified. This allows us to separate various types of mixtures. You could have solids dissolved, various liquids dissolved in one another, and mainly water and crude oil are two huge things that we talk about in terms of distillation. I've done chromatography before with ink. I know that's done in some classes, in some earlier science classes. We'll actually do it this year using food coloring. So chromatography is a physical separation again. All you're really doing is looking at how things kind of move on a piece of paper differently when they're dissolved in a solvent. So what you've probably done before, you might see something that looks a little bit like these samples up here. We're going to do something that looks a little bit more like what's on the paper over here, where you can actually see the separated ink spots, but we actually do that with food coloring. So this separates particles based on size or solubility, or both. Also, it can separate particles based on charge. If you're talking about gel electrophoresis, sorry. There are a lot of different types of chromatography. Some of them are very, very high tech. These can separate homogeneous and heterogeneous mixtures because it really depends on the type of chromatography that you're talking about. So this is a very widely applied type of separation tactic. It's used a lot to separate things in order to further analyze them. It's done frequently with computers and a lot of pieces of very expensive equipment. It can also be done as simply as with a paper towel. And that is it for your separation of a mixture.